This is Bitnar Talks, the engineer takes on construction. Episode 13. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved Documents Structure, Part 2. Hi there, and welcome back to the Bitnar Talks, your favorite podcast on all matters of architecture, engineering and construction. It is Thursday the 18th of August 2024, and I'm here back with you with the 13th episode and further information on approved documents. It has been yet another busy week, and I had the pleasure and opportunity to visit BAE Systems down in Rochester. It is great to see how the biggest employer or the second biggest employer, if you take the NHS into consideration within our neighborhood, is delivering groundbreaking technology to the aerospace, maritime and transportation industries. It was an excellent example of how the Six Sigmas and Lean's principles are being applied in the research and development driven organization. Not to mention the fact that I could use the simulators and fly some nice jets, including the fighter ones, with the top and newest technology on board. Last week in episode 12, I talked about the first two parts of requirement A, structures. I talked about the loading and ground movement and decided to talk about the disproportionate collapse separately in this episode. I did that due to the fact that the loading and ground movement requirements are straightforward to apply, but the aspects of disproportional collapse give some further complexity to the consideration of the structural safety of the building. Alright, so let us have a closer look at the subject. So without further ado, let's dive into the disproportionate collapse requirements of the approved document. Many good aspects of innovation are serendipitous in nature, and many aspects of law and our conscience are of the hindsight following a disaster. Such is the beginning of disproportionate collapse requirement, which started with a Ronan Point collapse on the 16th of May 1968, killing 4 people. If you don't know what Ronan Point collapse is, it is a 22-story residential tower made of concrete panels assembled on site. Unfortunately, the construction technique was not robust enough and lacking sufficient mechanical connection between the panels, which led to a catastrophic consequence of a localized failure. A gas explosion due to a leaking gas cooker connection pushed the walls out, allowing several stories over to collapse and in turn take the remaining bottom stories with them. Interestingly enough, the lady who fired up the kettle did not die from the force of the explosion, and it is being said that she even took the cooker with her to the next place. Apparently, she didn't take the kettle as it had quite a big dent in it, and apparently, due to this dent, a forensic engineering came up with the idea of what sort of pressure could have been exerted by that explosion, and settled on 34 kilonewtons per meter square. So here you have it, a localized accident leading to a large damage that is not proportionate to the cause is what the disproportionate collapse requirement is all about. In this episode, I will discuss the consideration that the Secretary of State draws our attention to and further expand on the consideration of risk and fire when it comes to building assessments. I will go section by section, giving you simple reasons behind the text and my commentary. Alright, so let's get on to it. The requirement A3, which is disproportionate collapse, is put in place to give us all-round more robust structures, taking in consideration the risk and consequence of their disproportionate collapse. As ever, the Secretary of State gives us his interpretation of the requirement and consideration that should form part of a structural safety consideration in section 5 of the approved documents, called reducing the sensitivity of the building to disproportionate collapse. So you see, it's not about elimination, but it's about reducing the sensitivity. As ever, with all of our law applications, with all our laws out there, we'll be dealing a lot with reasonable and reducing rather than giving you some concrete advice. Although, obviously, Secretary of State tries to do his best here. As we know, this is only guidance and argument should you ever need to protect your specification and build. But building control officers generally have no other way of knowing difference. So it is generally considered as a minimum standard, yet using it on its own does not mean the design and build complies with the requirement. The person who designs the project and specifies all the elements, and people who build them and then people who operate the building need to make their own judgment and need to assure that they know what they're doing. Okay, so what is it all about? It is about ensuring the building is robust enough for the consideration class it falls under. Consequences classes, as these are called, are simple divisions of buildings into groups, or rather classes for different and more stringent considerations. This follows the general philosophy of approved documents, starting with the guidance of approved documents and ends up with systematic analysis of the building from first principles in different failure scenarios. So what are the classes? What are we talking about when we talk about the consequences classes of buildings under the consideration of robustness, of disproportionate collapse? There are basically 4 classes identified by the guidance, by the approved document, but in fact there are 5, and the 5th is sui generis, which means outside of the scope of all of the 4 classes that are identified within the guidance. So the classes start from 1 and go to 3, with a split of class 2 to 2A and 2B. 2A being the lower risk group and the 2B being the upper risk group. And then class 3, which structural engineers like me love, like birds love honey. But let us go from lowest class first, shall we? Class 1 buildings are buildings that can be built using the non-engineered approach following approved documents. If you want to find out what the non-engineered approach is, I'd like you to guide you to the previous episode where I talk a little bit more about A1 and A2 consideration of the approved documents. Then we go to class 2A, which considers buildings that can follow the requirement of class 1 but need additional horizontal ties of the walls or need to make sure that the floors are held down to the wall. This requirement can be nearly read 1-to-1 with the reasons why the Ronan Point collapsed. Floor was not tied down to the walls and wall did not tie to the floor. So when the explosion happened, the floor have been lifted, releasing the walls from the slot, which were then pushed out and led to the catastrophic collapse. Class 2B goes a step further and requires horizontal and vertical ties between load-bearing elements. Slab to beam or wall, beam to column or wall, and vice versa. So all the structural elements carrying load should be tied somehow. Alternatively to the previous approaches, the building may be checked for stability and and the extent of damage by interrupting building system load path through the removal of supporting elements. So you can remove like a wall, a column, or a beam supporting column and see what happens. If no more than 15% of the story, limited to 100 meters squared, gets destroyed and the damage does not impact any other story, then the immediately over and under, the building is considered robust by the Secretary of State. But should the damage extend over the limit, the removed load-bearing element should be strong enough to take the pressure exerted upon it by explosion of leaking gas cooker, which is taken as 34 kilonewtons per meter square. If it can, the element gets a nickname and becomes known as key element. Then we go to class 3. Building in class 3 needs to be looked into with more care and understanding, taking in consideration all probable and reasonable possibilities of the building failure, including terrorist attacks and fire. So we know what needs to be done, but what on earth are these buildings? In section 5.3, the approved document goes on to elaborate on this. So for example, length of the wall considered for the removal will depend on the material and construction, and generally follows the panel story high and 2¼ story wide panels for concrete or internal walls panels, and otherwise the panel between lateral supports would be sufficient to be taken in consideration for the tributary load path of that panel to the key element. When considering the element for key element consideration, the explosion load should be considered vertically and laterally. So in both planes, explosion doesn't really happen only in one way, trying to push walls, but it also tries to push ceilings and floors. So it should be taken in this direction also. So buildings under consideration are as follows. Class 1 buildings are houses 4 stories and smaller, isolated buildings meaning with no immediate neighborhood or 1.5 times the building height away from. Buildings that in most cases will not impact more than a single large family if they collapse. Class 2A buildings are lower risk group, houses 5-story high if impacting only one family. Hotels, flats and offices up to 4 stories, 3-story industrial buildings, 3-story retail, but with a limit of 2,000 meters squared of floor area per story, single-story education buildings, public buildings of max 2 stories with a limit of 2,000 square meters of floor area per story. Class 2B buildings, which are upper risk group, includes accommodation, educational, office and retail buildings of up to 15 stories, hospitals up to 3 stories, public buildings up to 5,000 meters squares of floor area, and car parks up to 6 stories. Class 3 buildings are buildings which exceed the limits of previous classes and include grandstands over 5,000 spectators and special designation buildings dealing with hazardous substances and processes. Interestingly, basement stories may be excluded from the calculations of stories if they are at the least class 2B construction. So they're robust enough at the higher class, then they can be excluded from the calculation. For more complex buildings, risk may be evaluated and addressed by following recommendations of ISTRAC publications as an alternative approach or other publications referenced by the Secretary of State. Truth be told, you need to understand the possible risks and find a way to either mitigate on the worst case scenario or eliminate it. Did we think that the World Trade Center Twin Towers could be impacted by Boeing 767? No, but they did. Should we design all buildings for airplane impacts? I will leave you with this thought. Similarly, with the impact of earthquakes, the approved document does not require typical buildings of class 1 to 2B to be assessed in this way, but certainly class 3 buildings or unusual buildings should take this into account. In reality though, if you are in the earthquake prone area, you will likely do your assessment for any building that you design and provide minimum time to show some ductility in failure. The bottom line here is the relationship of the risk to the severity of failure, to its consequence, in relation to harm to people. Commercial risk is another kind of deliciousness, but here we talk about people safety in and around the building. And that leads us nicely to the risk. So what is risk in this disproportionate collapse? It is as in any other scenario. It is the combination of likelihood and severity of any given event. In structural engineering, we will identify the risk, then decide to eric the hell out of it. What does ericing the hell out of it means? It means either eliminate, reduce, inform, and control the risk. Or, if we cannot readily identify the issue, we will take an approach of limitation of consequences of localized failures, such as seen in the approaches with classes A to 2B. Any respectful engineer will look at the design from their perspective and from the perspective of possible risks, but that will be highly influenced by their wisdom, meaning well-winnowed experience and knowledge, not the years of experience, because that's irrelevant. In some circumstances, it may not be prudent to just follow the expectation of the approved document, and a risk evaluation may be better approach, especially when we modify existing buildings. So knowing what the risk is and what we're talking about here when we approach the robustness, one of the big risks on any given project and aspects that sort of fall outside or are not mentioned within the A3 requirements is fire. The requirement of the approved document is with local circumstances and mainly focuses on load path during accidental situation. One such accidental situation can be an event of fire that, albeit not acting momentarily, but usually impacting the entire compartment or a floor, and in this way possibly many load-bearing elements. The general approach to deal with fire in buildings is to isolate or reduce temperature influence of the given fire scenario on given load-bearing element by the provision of protection or oversizing that element. It would be unreasonable to build all type of buildings and then burn them down to the ground to provide accurate guidance, so we rely on elemental furnace testing and some typical topology buildings full-scale down to destruction fire testing. It is, however, impossible to account for all circumstances and for all qualities of execution to ascertain and make big optimizations the way the industry generally pushes to. The other interesting fact is that materials are often tested to standards that may fail to recognize all aspects of the given material, like the propagation of heat wave within the timber that may lead to a failure past the test finish, or simply to reflect the intensity and duration of the particular fire. Naturally, the temperature change of structural elements can lead to localized failures at the intersections with other elements, especially where the elements are restrained. Fire risk should be looked at from the perspective of a fire engineer who will analyze possible scenarios and structural engineers who will qualify the risk to the structure that such scenario brings about. Making sure the building remains robust under the fire condition may prove the most difficult design aspect of them all. So here you have it. Approved document A, requirement A3, disproportionate collapse. To sum up shortly, the requirement for disproportionate collapse aims to ensure buildings are robust enough to withstand various scenarios, considering the risk, its consequences of failure, and accounting for a certain level of uncertainty. The Secretary of State provides guidance through approved documents outlining different consequences classes. Classes 1, 2, 3, with increasing stringency as the number goes up. Class 1 buildings include small structures built to approved documents. Class 2A requires additional ties for stability, addressing risk identified during forensic investigation of the Ronan Point collapse. Class 2B necessitates horizontal and vertical ties between load-bearing elements. Alternatively, buildings can be tested by removing supporting elements. If damage remains localized, the structure is deemed robust. Class 3 buildings undergo comprehensive risk assessments, including factors like terrorist attacks and fire. Specific criteria determine which buildings fall in each class, considering factors like height, occupancy, and construction type. Basement stories may be exempt from calculations if built to a higher standard. For complex structures, alternative risk evaluation methods may be employed, balancing safety and commercial considerations. Fire safety is a crucial aspect, focusing on protecting load-bearing elements from temperature influence through insulation or oversizing. However, testing standards may not fully capture real-world scenarios for elemental fire approach. Engineers analyze fire risks in line with the fire engineer's evaluation of possible fire scenarios and their intensity to ensure structural integrity during and post the fire. Balancing risk, safety, and commercial interests, but focusing on protecting people's safety in and around buildings is paramount and the reason for a robust structural design. Thank you for staying with me all the way till now. I hope the added commentary and simple reasons behind the document's paragraphs made your understanding of the matter that little bit better. If you have any questions, reach out to me on LinkedIn or send me an email. I'm more than happy to help you out. You can book a non-obligatory consultation on our website www.bitnar.co.uk and ask a specific question if you like. Whether your question is if we can help you with your project or what should I do, we will be able to show you the right direction. At Bitnar, we help our clients design and execute their dream homes or investments. If your building is falling apart, we can also help investigating the reasons behind it and providing you with an appropriate strategy, design and specifications for the repair. Next week, I'll start talking about the requirement B, fire. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. Toodaloo!